The money market covers all lending for periods less than 1 year. What is the impact of the policy rate on the broader money market? The central bank will target a very short-term rate, usually an overnight lending rate. However, much of the lending in the money market will be for terms longer than overnight. In this segment, we develop the expectation theory of the term structure to think about the connection between the monetary policy rate and longer-term interest rates. Longer-term interest rates can be decomposed in an average of interest earned in the short term and forward rates. The interest is implicitly earned in future periods. Forward rates should be equal to the expectations of the future interest rate. After viewing this segment, you should be able to calculate the effect of policy rates on longer-term money market rates. Now let's get started.
Interest rate targets are usually set for the overnight market, or sometimes 1-week lending rate. However, interbank markets include lending over horizons of up to 1 year. It is useful to understand how monetary policy rates relate to those longer-term interest rates, since much economic activity will be financed with slightly longer-term lending. Consider this example. From the fall of 2010 through fall of 2011, when the Bank of Thailand began a cycle of raising the policy interest rate every 6 weeks, with the exception of one policy meeting early in 2011. As we have seen, overnight rates increase exactly with the policy rate. Longer-term interest rates for loans of 1 and 2 months in the interbank market rose in tandem. But interestingly, the longer-term interest rates anticipate the subsequent policy movements in the early part of 2011, with increases in longer-term rates preceding the increase in the short-term rate. This is because participants in the money market are forward-looking. The expectation theory of the term structure is used to explain interest rates over different maturity terms. Under the expectation theory, interest rates on money market lending are the average of monetary policy rates over the life of the loan. The logic is that lenders would not lend at rates lower than the total they could earn by lending each day in the overnight market, and competitive forces would keep lenders from demanding higher interest rates than the cost of financing in the short-term market. To be more specific, the interest rate on lending for N days should be equal to the average of the policy rate in the next N days. For example, on June 30th, 2011, the policy rate in Thailand was 3%. The overnight rate was on target at 3%. According to the expectation theory, the 1-week rate should be equal to the average of the policy rate today and the following 6 days. Given that the next meeting of the Monetary Policy Committee was not scheduled until 2 weeks later on July 13th, it would be reasonable to think that the policy rate would be in place over the next week. Therefore, the market might expect the policy overnight interest rate to remain at 3% for each of the next 7 days. Averaging a constant of 3% would be 3%, and indeed the 7-day, 1-week interest rate was 3%. But as the next meeting date drew nearer, the 1-week rate began to separate from the overnight rate. The overnight rate stayed on target, but the 1-week rate began to increase in anticipation of a policy change. We choose this example as it was a time period in which the Bank of Thailand was communicating that they would raise rates at the next meeting, making the next interest rate change expected. As expected, the interest rate went up to 3.25% and the two series reconverged. For example, on the morning of July 12th, you could lend overnight at 3%. The next morning, the 1-day rate would also be 3%. But that afternoon, the policy committee should raise interest rates to 3.25% for at least the next 6 weeks. If the expectation theory were true, the 1-week rate would be the average for these overnight rates. This equals 3.17857% compared to a measured interest rate of 3.18%. The theory was proved very accurate. Under the expectation theory, money market rates are the average of policy interest rates over the life of the loan. If the loan period covers an upcoming policy meeting, then the longer-term rate should be a prorated average of the policy rates before the meeting and the policy rates after the meeting. If the meeting is on day K, after the loan is made, this should be equal to a weighted average of the current policy rate and the expected future policy rate. Now that we've seen the prediction of the model, let's take a closer look at the 7-day interest rate leading up to the Bank of Thailand meeting on July 13, 2011. Take a closer look at the one-week interest rate leading up to the July 13, 2011 meeting in Thailand. For a 7-day loan, N equals 7. The original policy rate is 3%, and the expected post-meeting rate was 3.25%. More than 1 week before the meeting, the 7-day rate was about 3% as predicted by the theory. But on Friday, next week's meeting becomes relevant because the period will cover 1 day of lending at the post-meeting rate. Expectations theory says that the 1-week rate should initially be 3.04%, close to actual experience. When the market reopens the next Monday, 2 days later, there will be K equals 3 days before new interest rates are implemented. Expectations theory suggested interest rates would jump to 3.14%. In actuality, they only increased to 3.1%. As the week goes along and we get closer to the meeting, the post-meeting rates get more and more weight. Both the expectations theory prediction and the actual 1-week rate get closer and closer to 3.25. Finally, all rates go to 3.25% after the meeting. Not all rate changes are expected. Consider the most recent rate cut in Thailand on March 11, 2015. Though market participants knew a meeting would occur, they did not expect the interest rate to be cut. Thus, the 7-day interest rate did not adjust in the days prior to the meeting. Experience tells us interbank rates reflect the future path of monetary policy. In the next part of this segment, we'll study how the dynamics of a clear monetary policy stance impacts interbank rates over longer horizons.